Right. Yes, so I'm Alex Wainwright. I'm a research fellow in learning analytics at Monash University. You can see the link to my website here. I've got a new paper out, preprint on reevaluation of learning approaches questionnaire, which is quite interesting. So anyway, today I'll be presenting our paper titled Disciplinary Differences in Blended Learning Design and Network Analytics Study. I'd like to thank the other authors of this paper, including Yi, Shang, Kaylee, and Dragon, who are in the attendance at the moment. So the presentation will go as follows. I'll give a brief lit review of the learning activity offering research, and then that's going to follow into some limitations of this previous work and how our approach can resolve some of the limitations. So there's a growing move in higher education to the flipped classroom approach, wherein students study material before class and then apply the material within the classroom setting. Although motivated by a view of reducing passivity in education, there is a need to examine the outcomes of these changes in pedagogical practices. And typically, the approach has been to compare flipped to non-flipped classrooms. In the meta-analytic work of Van Alten, this has found students to be offered quizzes before class and group work within the classroom setting. And this shows that students are being exposed to a wider variety of activities than would be normally offered under traditional approaches, such as lectures. Now, other outcomes that have been measured are the impacts that active learning has had on student satisfaction, self-reported grades, and even assessed grades. Again, the meta-analytic work of Van Alten has reported small, albeit positive, effects of active learning on grade attainment. So for these authors, it was interpreted as being meaningful, giving some justifications to move towards an active learning approach. However, with self-reported grades, the effect was not significant, and this could be put down to the accuracy of self-report measures. And as for student satisfaction, Van Alten report equivalent levels of satisfaction between students in active learning setups to those in traditional learning setups. Now, active learning may not result in large effect sizes, although more work is required here to evaluate the approach in more depth. Yet we can see from this single meta-analytic study of Van Alten that students appear to perform better and are seemingly as satisfied when compared to passive approaches to education. In this way, an active learning approach should be encouraged, as it does not seem to be a detrimental effect on student outcomes. We know that disciplines do not follow the same approach in regards to the activities they offer to learners. To try and describe disciplinary differences, we can adopt the categorization of Newman that saw disciplines being described as pure or applied. Now, a pure discipline has been defined by those subjects wherein there's a focus on discovery and explanation. Applied is associated with the application of ideas to scenarios. And as a framework, it may be regarded as easy to understand, yet the ability to easily categorize disciplines using such terminology is not straightforward. So you'll often find that some disciplines combine many sub-disciplines whose categorization is quite fuzzy. Now, at Monash University, we have the Faculty of Medicine, which contains such things as social work, psychology, and physiology. So it's hard to say that these all fall under the categorization of applied. Now, for the present purpose, it is useful to keep this limitation in mind. So returning back to Newman's work, it was reported that applied disciplines focus on developing practical skills. This may be associated with professional practice, such as pharmacy, wherein students need strong communication skills to discuss medications when dealing with patients in the community. Pure disciplines are associated with the need to test ideas through argumentation. This would be commonplace with subjects such as psychology, when a student would have to collect and analyze data, and then any claims that they make, they would have to back up. So in other words, the student has to create an argument. So from this simple yet flawed framework, we can make some general inferences that there will be variations in the skills that disciplines teach, which is likely to require alternative approaches in terms of the activities students are offered. Now, there are alternative frameworks that have been used to categorize disciplines. Ballantyne adopted the STEM humanities approach and explored teaching practices of staff across various institutions. So it's generally found that lectures were a prominent activity offered. However, there were disciplinary differences with maths and sciences using technology to a greater extent. In the case of business, they were found to adopt the case study approach, and this was the same for health. And additional insights showed humanities to focus on developing critical evaluation skills, whilst health focused on developing professional practice. So what we can take away from this is that disciplines tend to offer variations in learning activities based upon the type of skills that they require their students to possess. The problem, however, is that the work that is cited is quite old. In the case of Ballantyne as well, they collected data by asking a sample of teaching staff across Australian universities to describe their teaching practices. And the total response rate was 708. So this is problematic because it's not a full representation of the teaching practices within a single university. And there is a case that responses may not be completely reliable. For example, there may be a social desirability element. So to reiterate, there are several limitations with previous work that has been undertaken to explore student activity offerings. Firstly, there is the focus on self-reports, and these often suffer from recall and social desirability bias, and this can affect the results accuracy. Secondly, there is the scope of the data collection. As previous research is only focused on individual teaching or a handful of classes across a large number of universities. Although this helps explore activity offerings across a number of universities, it doesn't really give you a complete picture of the activities being offered across a university in its entirety. So our alternative approach attempts to address both of these issues through the collection of more objective data. So as mentioned, given the limitations to self-reporting, we propose a more objective approach to understanding learning activity offering at a university. And this is achieved through obtaining data from two sources. The first, the learning management system, which in the case of Monash is Moodle, and also the timetabling system. So the learning management system allows the exploration into what activities a student's being offered in the online space, such as forums, resources, and quizzes, whereas the timetabling data shows us what in-class activities students are being offered across various disciplines. So in conjunction, both data sources provide insights into the move to blended learning at the university, both from a discipline and year level. We also explore the utility of analyzing this data through the use of epistemic network analysis, as this can provide a description of activity co-occurrence using different frames. So in our case, we can explore activity co-occurrence within an academic discipline, but also across disciplines. We could also expand this to look at activity change over time. which then allows for the exploration of possible trends in activity offerings to students. So for this work, we outlined 3 fairly general research questions that epistemic network analysis could answer. The first is to understand how various academic disciplines differ in regards to the activities, both physical and online, that they offer. So this extends the work of Ballantyne, but not only exploring physical learning activities in the larger sample, but also incorporating the offerings within the online space. The second research question sought to explore how we could leverage subtraction plots from epistemic network analysis, with a view of better understanding how faculties differ in regards to what is offered to students. This would show whether one faculty has higher co-occurrence of certain activity types than others. And finally, we have research question 3, which looked to explore whether activity offerings to students have changed over several years. So in this way, we could explore whether there's been a move towards more active learning teaching practices. So for our analyses, we use the following specifications. We source data from all 10 academic disciplines at Monash. So this includes arts, business, law, education, science, and information technology. We limited the data collection to the period of 2016 to 2019 and the 2 main semesters that ran here. So that's semester 1 and semester 2. And we were only concerned with the undergraduate courses, as these comprise the areas of active learning development at Monash. And in total, we were left with 6,040 courses in total. So with the physical learning activity, this was obtained through an extraction of the timetabling data at the university. And as you can see here, this is an example of what the data would look like. So it contains details on the course code, the discipline that owns the course, the year in which the activity was offered, the start time of the activity, and the activity name itself. There would be additional information contained here, but I've omitted this as it's not necessary. So this would involve the location of the activity, the planned size of the activity, and so on. And prior to 2019, Monash University didn't have a standardized approach to categorizing activity types. And this resulted in 262 unique activity codes being assigned to learning activities. And this led to a lot of confusion amongst staff and students, as there was no common ground, with students not knowing what type of activity they were attending. So a group was set up at the university with a view of creating a standardized typology, with the view of improving clarity of what activity a student was taking part in. And the 9 activity types are provided on the slide here. And there's a link here, which will take you to a list of definitions for each one of these. So for example, it'll say that workshop encompasses activities wherein students work within groups towards a common academic goal. These are usually large-scale setups with the instructor providing guidance to all the groups. In terms of online activities, we extracted all this from Moodle, and there were 19 activity types in total. And this covered such things as quiz, chats, resources, books, assignments, and so forth. And the issue is that the 19 activity codes is too high for the purpose of ENA. So we applied a categorization framework with the view of trying to reduce the scope of the data. So for this purpose, we adopted the Dawson et al. Coding. And this categorizes activities into one of the following. You can have administration type activities, and these may cover such things as announcements. Assessment would cover such things as quizzes and assignments. Content covers resources and books, and engagement are such things as forums and chats. Now, in regards to these online activities, we recognize that not all Moodle activities can be neatly subsumed under one of these categories, but it did allow us to reduce the complexity of the data itself. And once we applied these codings and we applied it to the data, this is what we were left with. So for course code 1, you can see that they were under the discipline of education. It was in 2017. They offered a lecture. They didn't offer an applied subject activity, and they did offer an online engagement activity. Was course code 2, was within pharmacy. It was in 2018. They didn't offer a lecture activity. They did offer an applied activity, and they did offer an engagement activity online. So now moving into the epistemic network analysis, the first thing we want to talk about is the specification we use. For our purpose, we use binary summation. The view was to reduce the skew in the data, which was caused by certain disciplines. So, for example, medicine often book activities individually. So a seminar would show up as 12 individual rows in the data, whereas education would have been a single row containing details on it being offered 8 times to students. In addition, we're only interested in the offering of an activity, not the frequency at which an activity was offered. So binary summation for our purpose here was fine. And the stanzas we selected were the courses nested within years, nested within academic discipline. So it's important to keep in mind that this work was exploratory. We had no criterion how many dimensions were to be extracted. And for the present purposes, we settled on extracting 2 dimensions. And this accounted for 54.4% of the variance in the data. 32.55% is associated with dimension 1, and that's the x-axis. And 21.85% is captured by dimension 2, and that's on the y-axis. And this is quite a substantial amount of variance we captured, yet there is a chance that we extracted too few dimensions. So there is additional follow-up work is necessary in order to understand whether more than 2 dimensions is required. Now, the plot on the left shows the centroids for the academic disciplines placed within 2-dimensional space. The first thing we can see is that art and design and architecture are uniquely positioned on the y-axis, whilst other academic disciplines do not vary much in relation to this. As for the x-axis, this appears to differentiate those academic disciplines that fall under the scope of humanities from those that lean towards STEM. Now, to understand why academic disciplines are positioned in the way they are, we can go and inspect the overall network plot, which is presented here on the right. Those activities that are online all begin with an O, and those that are physical all begin with a P. So what we can immediately see is that there are strong co-occurrences between the LMS activities. And this is understandable as a university generally has a minimum requirement of what is offered on Moodle. So it would be expected that students are offered content, engagement, and assessment activities together. What's more, given the general position of these LMS codes, we can make an inference that they're not important to differentiating academic disciplines. The physical activity code appear to be more important for this objective. Now, returning back to art, design, and architecture, we saw that they are far removed from the other academic disciplines. And the overall network plot indicates that this is where the studio-based activities lie. Now, art design and architecture rely on studio-based activities, as this allows students to complete creative work for their courses. And no other academic discipline utilizes studio-based activities to this extent. So it does show that the studio code is able to differentiate academic disciplines. Now, those disciplines that fall in the humanities, such as education, art, business, and law, are positioned where the codes of tutorial and seminar lie. This is understandable as education utilizes tutorials frequently, wherein students are expected to complete work under the supervision of a tutor. You can also see that this has links with both content and engagement. Again, the material in a tutorial is likely to be posted online, so co-occurrence is expected. Moving to the STEM-based disciplines, we can see that IT is positioned away from the remaining disciplines. And this is probably due to IT incorrectly classifying some activities under studios in 2016 and later reclassifying these under labs. Labs themselves can be seen to co-occur with content online and lectures. And given the purpose of a lab is to turn theoretical knowledge to practice, the connection with lectures and material in the LMS is to be expected. And finally, for pharmacy and medicine, which I'll position here, they're generally characterized by offering both practical and applied activities, wherein students applying their skills in the real world or in an assessed scenario, respectively. So what we can see here from this brief overview is that ENA allows us to explore disciplinary differences, but also why these differences are found. So research question 2 sought to explore what additional insights could be made through the use of subtraction plots. To exemplify this method, we focus on comparing disciplines that are well separated in dimensional space to show clearly how subtraction plots can be beneficial. So for this purpose, we chose pharmacy and arts. And this is what is presented on the screen here on the right. And pharmacy is in red and arts is in blue. Now, through this subtraction plot, we can see that arts has a greater co-occurrence of tutorial-based activities with online content and engagements, but also with lectures. Again, we can see that the materials provided within the LMS are going to be connected with the activities taking place within a tutorial. For arts as well, we can see a connection between tutorial and lecture. As tutorials may function as a way to expand on the subject matter covered in lectures, with a view the tutor attempting to resolve the questions that students may have. And as for pharmacy, we can see a greater number of connections between the activities being offered. And this essentially implies that students are being offered a greater diversity of activities. We can also see that lectures strongly co-occur with workshops. The workshop activities allow students to work in groups to build up on the content covered in the lecture. And it can also be seen that labs and practical activities co-occur more often in pharmacy. So with research question 3, this sought to explore how activity offerings have changed over time. This can be easily achieved with ENA. So rather than looking at the overall discipline centroids, we can look at the year stanza level for each discipline. Again, we chose those disciplines that are well separated in dimensional space. So on the left-hand side, you can see the 4-year centroids for art, design and architecture, arts and pharmacy. It can be seen that from 2016 to 2019, arts and design have shown little movement within the dimensional space. And this probably infers that there has been little to redevelop the courses over this period in terms of the activities they're offering to students. Pharmacy, on the other hand, has shown a shift from 2016 to 2019, going up along the y-axis. In isolation, this trajectory graph does little to convey how pharmacy has changed, but we can supplement this with a subtraction plot, comparing the networks from 2 years. The plot on the right is a comparison of pharmacy in 2016 and in 2019. So in 2016 is shown by the red lines and 2019 by the blue. And what we can generally see is that in 2016, there's a greater co-occurrence of practical, lecture, and tutorial activities. And these have generally been replaced in 2019 with applied workshop and lab activities. So it shows or implies that there has been a general move to a greater number of active learning activities to students. So in sum, we were able to address each of the 3 research questions using the approach of combining timetable and LMS data and analyzing it through ENA. We're able to show that ENA can be useful in visualizing academic discipline differences. What's more, the use of subtraction plots, we can begin to understand how differences in activity co-occurrence are shown across disciplines. And finally, with the use of trajectory and subtraction plots, we could visualize how activity offerings to students have changed over time. We've also reiterated the findings of Ballantyne. We have shown that teaching practice vary by academic disciplines, and we have shown that there does not appear to be a move, there does appear to be a move away from traditional approaches to learning activities that are more active learning based. And in using timetable and LMS data, we have reduced the impact of recall and social desirability biases, and we are able to explore longitudinal changes. There still remains limitations. We cannot claim that disciplines have moved to active learning approaches based on their own motivations. At Monash, we've redesigned learning spaces to encourage active learning approaches. So this is likely to be the reason for the changes we see. We also haven't explored the hours dedicated to an activity. We may see that still see lectures being offered to students, but the number of hours of lectures per student may have dropped. And this is the focus of future work. And finally, there's a view that the content of an activity does not equate to the activity name, and this is a potential source of bias in the data. Thank you for listening.